Hi, today we'll talk about next to heap coding pattern question, which is find right interval. This question gives us some intervals in an array, where that interval is a start and end, and we have to find the right interval of that particular interval at index 0, 1, 2, and so on. So what is meant by this means that if there is some intervals, let's suppose this example 2, and we were given some intervals 3, 4, 2, 3, 1, 2, then we have to tell that what is the right interval of this interval, which is at index 0, and what will be the right interval. Right interval means any other interval whose start time is greater than and equal to the end of this interval. So we can see obviously that there is no other interval for that particular interval whose start time is greater than the end or equal to the end time of this interval. So -1. There is no interval, right interval at this position. Then we'll look for this interval. We will say, okay, what is your right interval? So we will say that 3 is the end time of this interval, and start time of this interval at index 0 is 3. So obviously that is the right interval for this. So it is 0. Now when we talk about 1 and 2, 1 and 2 mean that what is the right interval whose start time is greater than and equal to 2. So we can see that this is 2, and we can see that 3. This interval starts at 2, and this interval starts at 3, but which is very closest, which is the minimized, for sure that one, because it starts at 2 and that ends at 2. So obviously that would be its right interval. Let's better understand with an example, and we will also understand that how it belongs to heap coding pattern, and then we'll go for the code. Now let's better understand the question. So suppose if we were given an interval 1, 2. In that case, there is no other interval, and we can't find the right interval. The answer will be -1. Now what if we have two intervals? Suppose 1 to 2 and 3 to 4. In that case, we can see that the second interval, its start time is greater than the end time of that particular interval, which is 2. So which is greater than 2. So 3 is greater than 2, and we can see that for this interval the right interval will be at index 1, and for that particular interval there is no right interval because its end time is 4, and we can't find any other interval whose start time is greater than or equal to 4. So we will see that it's -1. Now we can better, we understood the question. Now we will come to know that how it belongs to heap coding pattern. Well, now let's see how it belongs to heap coding pattern. So how it belongs to heap coding pattern, let's understand with an example. Suppose we have the same interval 1 to 2 and 3 to 4. Instead of looking these two intervals separately, we can consider them like a single interval, which starts at 2 and which starts at 1 and ends at 4. Break it at some point. In this example it is 2. So they make two intervals from that single interval, which is 1 to 2 and 3 to 4. And they were saying something that in some sequence like this one, that sequence, we have to find something which is in the middle. and in that case, which is maximum for one interval, like the end, and minimum at the other interval, which is start. We have two intervals now, and the one we have to look at the start end of that, and there is other interval where we have to look at the start of it. But there is a little tweak in this question. We can't use min heap and max heap because we were not given some single entity. We were given some interval like 1 to 2 or something, and 3 to 4, but we have to look at this part, like that part, which is the start of some interval, should be greater than of this part, which is end of some other interval. This is start, and this is start. So we have to find that this start should be greater than the end of this interval. So end is circle, and suppose this is square. We had to find some all start which are greater than the end of some other interval. Now we will know that why we are not going to use min heap and max heap. Rather, we are going to use max start heap, and we are going to use max end heap. And there might be you partially understand that why we have to use max start heap, because the start of each interval, like here, it could prove the right interval for any other interval. Now let's see how we can solve this question. So implementation part will be something like this. How we will implement? First we will take to heap, to max heap. That will be max start heap, and we will take also max end heap, max end heap. Now we have, let's suppose, some interval which is 3, 4, 1, 2, and 4, 5. We will take two max heap, the one which is max start heap, the other which is max end heap, and how they will sort the index, what will be inside those heap. The first thing we will add indices, because the answer is expected the index of the interval, which is right interval for any interval. Let's suppose, as we already see, 1, 2, and 3, 4, and we said that that the right interval for this interval will be 1 index, and that will be -1. So in these max heap we will save indices. Now how they will be sorted, what sorting it will use for adding indexes. So let's suppose we talk about max start heap first. We will say, okay, take 0. It will look into that interval and says what is your start, and I will find other indexes which will be in main, and I will check with that start. So on the basis of this start, I am a max start heap, so it will just look into that part. It's very simple then. So we will say take 0. It says okay, I can see that 3 is the only one and it's maximum. Now we say take 1. When we will say take 1, it will look that its max start heap is 1, and see I have an index of 0, and it will look for its start and compare that one. So it will say, okay, now this is it will go on the top and one will go below. So it will reorder that. It will say that 0 index start is maximum and 1 has start less than 3. So it will reorder like this. When we will add 2, it will say, now what is your start? It will say my start is 4, and it will compare with the previous one, which is 1 and 3. So it will say, okay, that is maximum. So it will keep 2 here. The same thing will go with our max and heap. What it will do, we will say take the index of 0. It will look into that and say there is no other interval, so it is maximum. So it will put 0 index here. Now we will say go, and so this is 0 index, 1 and 2. We will say go for index 1, and it will look into the end of this and compare it with that. So it says, okay, I have to reorder. So index 1 will go below, 0 will go up. So it will rearrange like that. Now we will say go for index 2. It will see its end, and that 5 is maximum for both of them, from here and from here. So these will be our 2 max heap. Now some answer, which is an array that will be a size of number of intervals. Now we will pick that interval from the max and heap, which is the top one. We will say, okay, this is the index of the interval whose end is maximum. We will get that and try to compare all the intervals whose start is maximum. How we will compare that? So what we will do first, what we will dequeue max and heap. We will get some index which will be the max end, something like that. Now we will try to find, in our case, in this example, it is 5. So this is 5. So in this case, max will be 5. Now we will try to find in our max start heap that is there the index which is on the top, does its start time is greater than or equal to that max end, equal to 4, and we doesn't find that. If we doesn't find, so for sure that particular index will be -1. We will go for the next, and we say, okay, this was being dequeued. In that case, 2 is gone. Now we will look into the next interval. We will say this is the max end heap. We get this time max end, which will be, we dequeue from the max end heap, and the value will be actually the index of 0. Now we will look into our max start heap again, and we will say whatever the index on the top, its start time is maximum. We will get that interval, compare it, and now we can see that this end time is equal to the start of this interval, which is an index 2. Max start is our 2. The index is 2, and in that index is actually pointing the interval that is 4, 5, and this max end is the index is pointing interval 3 and 4, and we can see that this interval start is equal to the end of this interval. So we know that we found that, but we will try to go further to find the closest. But let's suppose if we think this is a complete interval, that is 2 to 3 and 3 to 6 and 4 to 5. So right interval for this interval is that one, because its start time is equal to the end time of this, not that one. Even it will be the maximum, but it won't be the right interval for this. So we have to while here and keep on looking for next closest while loop next closest start, because that will be the right interval for the particle interval. And once we will complete our whole search, we will enqueue that max start again, because it could be possible the next right interval for any other interval. So we will enqueue it back. Now let's go back to the code and we will better understand. Now let's see how we can implement our code. We have to get initially to, that will be the first step, we'll get to max heap. Second, we will fill them. Second step, we will fill those fill max heaps. Third, we will look into each interval, like each max heap, and then we will try to see that if it is less than equal to the start of any max start heap interval. So, and then we will keep on dequeuing that. We will, in the first step, we will try to keep on dequeuing the max start heap so that we can get which is the closest in right interval. And that's it. These are the first step. So let's see how we can implement that. First, we will go and say max start heap. So max start heap is a priority queue. Priority queue of int because we were going to populate that with indices, and then we will say ordering dot from less than to the provided intervals, and its head should be the maximum head if all other intervals available in it. So we'll say intervals dot head. Periodic queue is mutable collection, so we'll say import Scala dot collection dot mutable and everything, suppose. Well, we will go and get max and heap, and it is a priority queue, and it will be of indices, that's why it's an int, and ordering dot from less than, okay, typo, thanks, not thanks, it's less than, so intervals of last, so we were going to order it on the basis of its end, and that should be intervals, typo here, intervals of dot last. Now these are the number of intervals. We'll say intervals dot length, and we'll say answer will be possibly array dot of dimension. It is of type int because we have to return the answer in the indices of the interval, which are the right interval of that interval. Okay, so it will be of size n. And now we will go and populate both in the second step. We are here, so we will go and fill those max heap, and we say, okay, we say for, we go I from 0 to 0 until n, and we say max start heap dot enqueue with that index, and we go and say max and heap dot enqueue with that index also. Third step, and the third step that we will iterate on all max and heap. Compare, okay, we have to dequeue from our max and heap. It should be a dequeue from max and heap and compare with the max start heap intervals. Yes. So we will go again from I to 0 to 0 until n, and here we will first say that this is all max and this is the maximum end of the interval in the available intervals. So that would be max end heap dot dq. Now answer if that max end would be possibly -1. Because we won't get anything, then it is -1. Now where we will populate that if it is not -1. Let's say we can say while we will say, we already looping on the top, so if we say if max start heap dot non-empty, so we will say it's not empty, and then we will try to find that intervals max start heap. We'll say max start heap dot head mean that we are looking whatever is on the top of max start heap, its start is greater than or equal to intervals at max end dot last. It's max start heap which is greater than or equal to the end of that interval. Now after that, if we found something, we said okay, that is the possible it will be a max start heap. It's a max start, and we say max start heap dot dq, and now we say okay, find the next closest, find your next closest start time, and we say okay, while we max start heap until it is not empty. We keep on looking and say intervals should be max start heap dot head. Dot head is we are asking the same question with each interval, if or u greater than, because we are going to find the closest one. So you say max end dot last, and we keep on looking for that until we get closest max start. So say max start heap dot dq. We keep on dequeuing that, and then we say answer will be the max end would be that max start. This is the particle index, which will be the max closest start of u, and we say max start heap dot enqueue. We are enqueuing that, and we can at the end return the answer. So let's run the code and see if everything is fine. Well, it works fine, and that's it. Thank you.